on recording. Yeah, so welcome to this session. This is part of the Hard Skills event at TE Academy. We'll talk about machinations today and see their presentation of the tool and also a case, an applied case in token engineering. But before we kick off this presentation, let me say some words about TE Academy for those who don't know it yet. Now we have an echo. No, okay, it's fine. So what is token engineering? For those who haven't heard about this new discipline, it's basically an emerging discipline, the youngest engineering discipline after software engineering was established in the 1960s. And it's focused on the design, validation, optimization of crypto economic systems, token-based systems. So it's a crypto native discipline. And TE Academy has the mission. We started in 2018 with community activities, now kicked off or launched the Academy in 2020 with the mission to provide education in this new sector, also certification to enable token engineers to prove their skills and experience, and matchmaking to crypto projects, since there is a lot of demand for skilled token engineers. Some facts. We kicked off our programs in July 2020. Since then, had more than 900 active participants in our programs. Now we are building TE Fundamentals, the first comprehensive education and certification program in this field. And in less than 8 weeks, we had more than 1,000 signups. People, oh wait, can we? Yeah, please switch off your mics. Thanks. Mainly people with a background in economics, math, physics, finance, data science, but of course other like political science for the DAO area and computer science, obviously. TE Fundamentals will be available in Q3. It's an online course, so you can take part from basically all around the globe. And the TE 360 program is already live. To get ready for it, and Patty will certainly drop a link to the chat. Our vision for engineering new economies in Web3 is rather, instead of building out systems that trying to optimize humans, like manipulate with incentive, it's try to provide the maximum degree of freedom in these economies while preventing dangerous conditions. And simulations are certainly part of it. And Machinations is a great tool coming first application cases in game theory and gaming industry, but now of course this is becoming pretty interesting for the crypto economic sector as well. And today we have Machinations in this hard skills program. Welcome Matthew Morris from the Machinations team, and he will now give us an overview on this framework and toolset.
Perfect. Thank you very much, Angela. I'm actually here with a couple of my colleagues. Mihai and Axon are here. They're waving in chat. Please do, as I'm going through today's kind of presentation, walking you through a little bit of the Machinations platform. If you have any questions, please do ask them in chat, or just take yourself off mute and ask a question. Love to make this as interactive as possible rather than me just talking at you for the next 20 minutes or so. To put a bit of context into Machinations, been around for a few years. We've got about 35,000 game designers registered on the platform, and people using it from all sorts of backgrounds and organizations, ranging from Microsoft, Ubisoft's, Paradoxes of the world, all the way through to new game designers learning kind of the core mechanics of game design and learning how to build their very first games. I'm going to open up and share my screen and kind of walk through the platform a little bit. And during this process, I'm going to kind of explain a little bit about the Machinations platform and what it does, really hopefully try and put this into context for you when it comes to tokenomics design and understanding some tokenomics theories and some of the best practices that we've developed to kind of help people get ready for the launch of their projects. Now, the Machinations platform uses these 11 objects down the left-hand side to create any type of game logic or any type of system. If you can think it, you can design it and start building it out in Machinations. The real power of the platform is once you've built these flows and you started to design them, you can actually hit play and watch them play out and see how these mechanics will work and how they'll operate. So within a few minutes, you can start to build up any type of mechanic. Now, let's just talk about the challenge that we face in the world of Web3 when it comes to token design. Right the way down at the very core of most games, there's this very core principle loop that we have where the player plays a game, they earn some type of reward, they then reinvest that reward back into the game to level up or progress in some way, which then aids their progression in the future. In games, we'd say, they receive a new item, a new sword or piece of armor, they level up their character stats, or maybe they just unlock the next puzzle or unlock the next section of the storyline. Now, we're moving into Web3 games, we've got a new path that we're introducing to players where they now have the ability to sell some of these rewards out via the blockchain and maybe exchange them for other items or potentially even cash out of the game. Where this starts to get challenging is there's not just one loop with one player going through this at the same time. We have a huge number of these progression systems happening all the time with players interacting with the economy in different ways. They're logging in different amounts of time. They have different play styles. They focus on different areas of the gameplay. And most importantly, they're interacting with the economy in different ways. Now, in the world of Web2 games, the way in which players interact with the economy, these are all isolated, they're all separate. Your progression experience in the one game would be very different to how somebody else could be progressing through it, but it didn't matter, they were separate from you. In Web3, we're now using blockchain technology to link these players together through the markets, through the token exchanges, to create a single game economy impacting our tokenomics. Players aren't just selling items, they're also purchasing NFTs, they're purchasing tokens, and suddenly we start to get quite a complex system of events going on. More importantly, to add extra complexity to it, the value of our tokens is often then pinned to a cryptocurrency, which is also impacted externally in the marketplace. So now we've got a single economy, which is very, very complex. And more importantly, it's very difficult to understand where the different levers are that we have to control our tokens and to control our token values. You think about any type of Web3 game, especially how many different areas there are that control the number of tokens a player could be receiving as a reward, what sort of activity they have to do to achieve that, what sort of costs or drains there are for the player to sink those tokens into, all have a massive impact on the overall tokenomics of a gameplay. This is where Machinations comes in as a way of visualizing and starting to test out different approaches and different theories around tokenomics to really be able to understand how these systems come together and what we can do as game designers to control the flow of our tokens. I'll pause there for a second. I don't know if there's any questions in chat so far, otherwise I'll carry on. If anybody has any questions, please do just drop them into the chat or come off mute and ask me.
Yeah, feel free to drop your questions in the chat, and also let's take a moment because I think it's important to have a good understanding of the underlying paradigm, the definition of the component. So if you have any questions here before we move on, switch on your mic or drop a message to the chat. Okay, there we go.
Perfect.
How do you model? Sorry.
So how do we model the price and value, and actually how do we look at different types of marketplaces? So actually that's perfect. I'm going to move on now. I've kind of given you an introduction to the platform. I'm going to move into a slightly more complex model. These models can get exceedingly complex. This model has got only 130 odd components. We've got models that go into thousands of components, and we really go into kind of very, very minute detail on the exact mechanics. What we're doing here, we've got a system that's testing and modeling our core gameplay mechanics. We also, in this model, I'm actually simulating an AMM. So I've built a simple constant value AMM inside Machinations. So I can use this to start testing how the game mechanics are going to interact with our token values via that AMM. There's a couple of play styles in Machinations. So just earlier I was showing you our normal kind of animated plays. We also have this system called batch play. What happens when we're doing a batch play is we take the model, we send it up to the cloud, and then we run multiple parallel streams of the simulation. The reason that we do this is so that we can really build up relevant statistical reliability on the data that we've created. Machinations is using Monte Carlo simulations. And the best way to think of Monte Carlo simulations is if you were to flip a coin 10 times in a row, a spreadsheet will tell you, well, there's a 50-50 chance of it landing on heads or tails. Therefore, if you flip a coin 10 times in a row, you'll have 5 heads, 5 tails. Now, in reality, if you actually flip a coin 10 times in a row, it's very rare that you'll even get 5 heads, 5 tails. What you're actually going to get is a huge range of different results. And the way Machinations works with Monte Carlo is that rather than applying a fixed percentage as to the potential outcome, we're effectively re-rolling that dice each time and using Monte Carlo to build up statistically relevant data. So that's why we have these systems that then allow us to really build up data very, very quickly and start to run multiple parallel streams so that we can start to create enough data before a title's even launched, or before a system's even launched, so that we can have some certainty around what those potential outcomes could be. So actually, someone's just kind of noticed that. So when I was running it, someone said, gate drop 25% resources more than 5 steps. That's exactly that Monte Carlo simulation in action. So although it's 25%, it doesn't mean that 1 in 4 resources are going to go through that gate. It means that there's going to be a 25% probability of each resource going through that gate. So you'll get a very different set of results each time. Now, what this model is showing me is I'm running a 1.5 year long predictive model inside Machinations. This purple line is showing the Ethereum blockchain price. The purpose of this demo, I've taken some historical data of Ethereum, and I'm looking at how much money a play-to-earn style persona could make inside this game. So this type of persona is someone that logs into the game each day. They create as many tokens as they can, and then we will they'll sell those tokens to make a quick buck. Starts off really healthy at the beginning of our simulation here. We're generating about $4.50. It's actually spiking up to about $15, which is really great. That's mostly driven by the Ethereum price increase. But then after that, it starts to dwindle off, and actually we're dropping down to those player personas earning about 30 cents in about 1.5 years' time. The reason for this is we're creating too many tokens and we're flooding the market with them. There aren't enough sinks or enough demand for those tokens in any of the gameplay. So because we've got an excess of token, insufficient demand for them, we're causing inflation, and our token values are dropping right down. The great thing about Machinations is that by constantly running these models and looking at live data, ingesting that back into Machinations, we can start to really build up some solid forecasts of the potential output of our token values in the future. What I've just done is I've just adjusted the number of tokens that a player can earn in that type of persona to create some additional restriction. There would be, in reality, there's probably a dozen or so places that we could look to move those levers that control our economy and adjust how many tokens the player is receiving, where the sinks are, increasing those sinks. But now what I'm going to do is rerun my predictive model to look at how making this change of reducing those number of tokens, what impact that's going to have on our game economy. So the data is already coming back. Because I'm restricting the number of tokens at first, starting off a little bit lower, but actually it's driving our token price up much higher. So now we're peaking at about $18, but more importantly, I've got a much higher long-term token value into the future. And by using Machinations, we can then start to build up our data to look at how these different personas could interact with our economy and what impact they could have across our game economy. I see there's a few questions in chat. Let me see. Questions. What are the basic types of models? How to balance between value and liquidity? That's a great question. And actually, there's lots of different ways that I could probably spend about an hour just on that one subject, actually. But really, it's about understanding how the different mechanics play out, how different players could interact with the economy, to be able to kind of start testing the game balance, and then looking at the different types of situations going into the future. So Machinations isn't a crystal ball that will tell you the future and tell you what's going to happen. Machinations is a way of testing your different scenarios and different situations to see what could happen in the future. I think there was another question.
Yeah, there were a lot of questions on templates. Do you have some templates from existing token projects?
Yes, actually, so we've got a number of projects across our community. So on our community, we've got a huge number of models that have been created by different members of our community. So you can come into Machinations, you can sign up for the platform for free, start using the platform. There's an incredibly beautiful model that Kaiju Kings have created as part of their project to get their economy ready. A lot of the models that we create as part of the kind of the content we share in the community as well, which you can come in and get hold of. We're planning to do a session in the near future, purely focusing on AMMs. AMMs are a particularly tricky part to model, or can be very complex to understand. So one of the things we're going to be doing is just doing a session dedicated to these, look at how different types of AMMs can impact your game economy. But we'll be doing a lot more kind of content on that in the future, and sharing all of the models so that you can, in the future, just better grab an AMM and drop it into your model to start testing.
And there's another question also on the question of libraries, templates. Is there a library of type of personas or agents that reflect behavior off the shelf?
So we've done quite a lot of content kind of helping people understand how different personas and kind of some of the benchmarks of kind of industry best practices that us, as well as a few different organizations, have created to understand how different player personas, especially in the Web3 world, will interact with games. Every single game is its own unique snowflake. So often the way in which different personas will interact with it will be different each time. And that's really a case of kind of working through the process to really to think about what type of player personas you're looking to attract into your project. So
I can also contribute something there. So we have diagrams where we modeled personas using simple elements like some pools, values, and formulas. But we also have diagrams where we infer personas from actual blockchain data. So we have a project where we are getting data from blockchain, and we can get the personas. But some of this is, as Matthew said, very game specific. So it depends sometimes from customer to customer and integration to integration.
But is this something you do like as a service, or is this also part of your community, open source, let's say, this Machinations description of behavior to plug in to other Machinations models?
Actually, we've got a bit of both. So Machinations, we've produced a lot of content to kind of help people understand how to start approaching persona models. And we've got a couple of YouTube videos that we've done to kind of help designers go through that process. About a month or so ago, we launched a brand new service where we call it the Verified by Machinations service. And in this service, the Machinations diagram architects actually work with Web3 games, and we go through and we build out these models. So we build out a model that allows us to simulate the single player journey. Once we've built out a model that allows us to simulate a player's experience inside the game, the Machinations team actually go through, work with the game designers or the game developer to build out how these personas would interact with the economy. And then we actually build out the full macro economy to show teams what could happen potentially with their game once it goes into production. Big part of this is that at the end of that type of process, we then award that project the verified by Machinations logo to say they've been through this quite rigorous auditing process of their game design processes, and to show that they do have a sustainable game economy.
Cool. There's another question, and this is also related to, okay, who are the users? So my question would be, typically, who are the users of Machinations in, if your first experience designing token economies?
So, I mean, we tend to see a huge range of different type of users inside Machinations, ranging from kind of game designers who are looking to kind of balance their games, all the way through to kind of people that are just looking at the economic models and want to be able to leverage Monte Carlo simulations to understand what could happen when their product gets into production, and look at those different types of scenarios. We did a survey recently and kind of tested to see how long it takes people to learn Machinations, and that came back at 4.2 hours as the amount of time it takes for teams to, or for an individual to come into Machinations, sign up for an account, and get to the point where they can really start to build out models and start testing their economies.
All right. And there was another related question from Dimitrios. What is the skill set needed for somebody working with Machinations?
That's a great question. I think one of the big challenges, I think, that you have to overcome when you're working in a platform like Machinations is a level of abstract thinking. There's no beautiful graphics in Machinations. There's no, iconography. It's using a very, very simple visual language to represent how different game mechanics work. One of the things that we find is it's finding the balance of how much do you want to abstract away from reality. You're not going to, in fact, I did find someone building a Machinations model where they were calculating the bullet travel time in a first-person shooter game, and in the same model, they were trying to simulate the entire macro economy. Now, bullet travel time, amazing. You could probably build a model just for that if you really wanted to, but actually, you're not going to get a huge amount of value when the output that you want is going to be the macro economy and what's the interaction that the player is going to have with the economy. So really, I think having an analytical approach where you can understand abstract applications of kind of game design theory are very, very helpful. But if you've played a game before and you start learning the Machinations language, you very quickly start to understand how mechanics can be applied. So now when I start playing a game, I immediately start thinking about the Machinations model of it. And it's amazing when you can start applying that to absolutely any game system.
All right, there's more. If I may drop some more questions. Of course, super exciting question. Luis asked, is it possible to model DAOs, interactions and simulations in Machinations? And Axon already replied, but maybe you want to elaborate on that one.
Yeah, absolutely. So we're working with a number of DAO projects at the moment. We're looking at their kind of core gameplay and their game balance and their game economy balance. But as DAOs, they're looking at how different types of situations, different kind of changes to the DAO, what sort of impact that could have on their overall economy. So certainly when we're looking at, I was looking at the Cult DAO recently in terms of the model that they created where every time there's a new proposal put forward and there's a new vote, it's burning down an element of the tokens, modeling all of that inside Machinations so that we can start to build up predictive models of what could happen with the number of kind of tokens in circulation in the future. And it's a great way of kind of approaching it above and beyond what a spreadsheet can do, because a spreadsheet will kind of give you the one answer and say this is going to be the output of the DAO. But actually running it through Monte Carlo processes where you can then look at, well, what happens if there's a huge number of proposals put forward or a very small number of proposals put forward, and look at all the different what if scenarios that could happen in the future is a great way to kind of really understand the potential of those sorts of projects.
Cool. Before we continue, because we have around 20 more questions in the chat, let's quickly check. Jake from LTF, are you here in the channel? Okay, I just wanted to double check. You are ready for presenting your case in a minute?
I'm ready, Angela.
Okay, perfect.
If you want to field some questions, you can, but I am ready to go.
Okay, let's take 2 more questions and then we dig into a particular case. I just noted one message in the chat. Mihai, by the way, the founder of Machinations.io, there was a question on how long does it take to learn Machinations, the language? And you say it takes 4.2 hours on average. That's nice. How do you measure?
We did a study when there were roughly 18,000 registered users, so about half of what they are now. We literally asked them how long it took and did the average. But again, it varies. For some people, it's actually a couple of days. Mm-hmm. For others, especially developers, the analytical thinking and the objectual kind of, object programming really helps. Someone with an engineering background that's seen state diagrams or Petri nets, those types of, if you have that experience, you might pick it up in less than an hour. Preferred means of learning are documentation, watching YouTube tutorials, opening up templates. There's hundreds of them that you can find actually within the app. And actually the 4th method is just random point and click until you get it. That actually works, even though the interface doesn't quite help. Machinations plus machine learning equals OP. Yes, Matthew, it's going to be very OP. That's the stage 3 of our development. Stage 1 was just the tool. Stage 2 is API and data ingestion, where we are now. Stage 3 is once we'll have the simulations and the actual data of what happened, we can match those two and put the machine to good use to start getting more accurate forecasts. Stage 4 is actually going to be AI, where the machine will be able to execute rule sets on live systems based on what instructions you gave it.
Running machine. We've done an experiment on running machine learning agents on diagrams and finding weak spots in the economy. That's kind of the holy grail, one of them at least. But it's in the works.
And okay, Matt, about data from external sources, Axon, you answered that. But yes, it's, probably half of the parameters that Matthew showed in that diagram are assumptions. So make informed assumptions, maybe you have some benchmark, or maybe you've seen other systems, but nothing beats actual data. So once the systems start coming to life and you have your telemetry in place, or you can scrape blockchains, you can take those KPIs, put them back into the diagram, and when you do the simulations, these get more and more accurate. So think of it as a process of calibrating. It's assumptions before launch, it's actual data, and simulations on actual data after you've deployed the system.
All right, thank you for this. There were more questions regarding how does CatCat, Token Spice, frameworks that are already, let's say, used in the crypto economics sector and Machinations compare. Maybe we'll get to that at the end, and I invite now Jake on stage. Jake is member of the LTF community, Longtail Financial, and you are active in the crypto sector for a while, designing crypto economic systems, particularly in finance. And you have been working recently with Machinations for simulations. Jake, I'm happy that you're here. The stage is yours. I'm excited to see your model.
Thank you, Angela. Yeah, hi, everyone. I'm Jake Cassani. I'm the CTO at Longtail Financial. And like Angela said, we specialize in advanced token models across the board. And we do specialize in finance, but we have done numerous our own simulations for play to earn and NFT games ourselves. But first and foremost, a couple of things. One, guys, I didn't find Machinations just about a month ago. And when I dived in, it did seem a bit daunting at first, but now finding out that the roughly average is 4.2 hours, I probably did it in like 3 something. So I feel really good about myself. Now I will attest to the documentation's great. It's worth spending your time going through the tutorials. There are numerous templates to really try and wrap your head around before you get into the complex ones. Their basic Web3 NFT one is just a great place to start and seeing what does what. And then just pulling pieces, parts, and just understanding what's going on, especially when you start putting things in place and then they go black on you, they go gray, they gray out, and you're like, why did it gray out? Why doesn't it work? It worked, no, it doesn't work. But just playing around with it is the best way to use this thing, and start small and build out. Okay. Oh, and Matthew, and everybody, all you guys, this thing is a godsend to me. I am in love with it. So I just want you to know, thank you very much. Very much. All right. I have a quick slide I want to present on LTF with Machinations, and then I will get right into the use case and the demonstration of a PID controller for a current client of ours, All Access Anonymous, who has given us permission to show it. Okay. Okay. Is everything good? Can you see our beautiful little logos? Okay, fantastic. Yeah, so ways LTF can use Machinations. Learn the fundamentals of token engineering. We specialize ourselves in Monte Carlo systems. We use math and system flow design, married with the Machinations program, opens up possibilities to new learnings for users. The big thing too that was already talked about early is this as a giant educational tool is monumental. For what we can do as far as the TE Academy, what Longtail likes to also really be behind and backing is the education of this space. We are engineers and we are in a whole new field, and the biggest point of that is education. And this, in what you described, Matthew, in the simplicity is actually the profound implication of it, because it's visual. And most of us are visual learning creatures. I know I am. But the capability of this to just show not just clients, but anyone, hey guys, this is what it actually looks like. This is what it's actually going to do, is gigantic, because there is a huge language barrier, and there are actual similar words that come across. Like in token engineering, we use a lot of flow design. That's stock and flow is a big part in how we describe and use things. But there is stock and flow in game design, especially with pools and drains. And so we already have some similarities that we can build off of. We're already closing that gap. And that's the language is huge, right? That's the big thing we're trying to get through. And as an educational tool, that's monumental. As far as also protocol development, game strategies, testing reward systems of all kinds, testing existing game theories, the application for us to go over projects and protocols that are already done, but may or may not actually know what could happen, looking for exploits, anything else. And then of course, testing new game theories and putting it really to work is extremely exciting for us. And again, we do play with your every move. We're really excited about this. For instance, the PID controller application across Web3, for instance, a liquidity flow, we have an internal model we're working on for ourselves that we're calling Panama, but this, the PID application, and that's what I'm going to show you, is huge. And we're really excited about this. All Access Anonymous is extremely excited about this. And we've gotten a lot of interest across the space for more further analysis and simulation of a PID controller across the board. And again, like the DeFi breakdowns, modeling existing protocols, testing existing DeFi strategies again, and new yield farm strategies as well. Like you showed earlier in yours, Matthew, that how it can get very complex. Now you're representing individual players, but that could be individual protocols. They could all be going into various automated market makers could be a part of it, DEX aggregators, the entire thing could actually be there. And to actually think about what, like, if you just modeled out Curve, if you modeled out all of Curve and what it would look like would just be incredible, right? Like that's big, but it's exciting stuff. Some of the ways that we can better use Machinations to work in tandem for developers. One big one is tokenomics, the understanding of stock and flow design systems. A use case, bringing in LTF token engineering experience along with the TE Academy into the Machinations system. I think one of the biggest ones is actually security. I think that's really incredible because again, we get back to the education, having more people aware on what and how better modeling and building should be done. And with systems like yours and the visualization power, and somebody brought up Token Spice, you're probably not that familiar with it, but it is an agent-based modeling system to validate smart contracts. It's real cutting edge stuff. And again, because it's agent-based, there's a lot of opportunity there to actually visualize contract interaction. Like that's pretty incredible stuff. Testing units for each ideation as far as, the testing itself, and then having overall an index, a library of models and patterns across the board that we can all just utilize as far as, us being data scientists and how much we love data. I must have data. Advantages for LTF, outlining token designs because it is our business. Using LTF's in-house application, we have our own app and insights into using industry benchmark practices. We have a competitive advantage with math and data science programming. Proven experience with partners for the past 12 months. We've actually been working and deep understanding of existing protocols across the board. And again, the same language across the space is the absolute just fundamental thing I really want to hammer here that we're excited about. Now with that, I will get right into, I'm going to have to stop this video again and get into my other one. Hold on a second here. Forgive me. I'm not the biggest on Zoom.
What's the problem, Jake?
Yeah, just give me a second.
Okay.
Well, that was it.
Zoom is a real pain sometimes. Sometimes it's great, and then other times it's like, no, that's it. It's not playing.
Yeah.
21st century is somewhat of a disappointment sometimes when it comes to the ease of doing these things.
We've come so far, haven't we? I mean, anyways. Okay, I think I got her now.
Oh, nice.
Okay, do we have it? Great, fantastic, yes. All right. Anyways, I'll try and give, before I dive into this thing, All Access Anonymous is actually quite a huge protocol, and it's bringing in a lot. They already have an established company that's in the concert venue business in Southeast Asia. They have over 1 million in their user base already, and they provide that venue experience. They work with vendors firsthand and then supply ticket sales and set up venues, and that's their whole big precedent as a business. And they've done very well. Well, now they want to try and bring it in to blockchain. So they came to us, and they're going to have a whole front end that's designed off of NFTs for tickets. That's one application. On the back end, they wanted to actually be able to utilize open finance to better manage their treasury. And so this protocol is a built up hybrid on not just an Olympus fork, but a part of it is it's in its nature, but it also there's quite a bit of other things going on here. We helped them design this out and then offer the opportunity to apply a PID controller in the sense of better managing the inflation rates that go on between each step of staking. Because a big problem with Olympus is the managing of inflation between each staking mechanism. What this PID controller is showing is dollars coming into the treasury, then those minting AAA tokens itself as the native asset. You would then stake the AAA token to make staked AAA token, a separate new token. You'd stake that and mint wrap staked AAA token. And then of course, then can be redeemed for an actual stable, or it can go back to paying back the loan, which is a part of the mechanism for the lending pool system, because clients and vendors are going to borrow from this actual protocol to put on venues. They can also redeem for payment by double staking to pay back their loan with the wrap staked own. This thing can then be sent back to the treasury as they mint A to redeem and keep the reserve asset. It also has the point of a algorithmic stable coin built in, where they will then burn their native asset to mint their stable coin, which will then also be sent back to the lending pool. It also comes back to the treasury in a different model. But without trying to get into too much of the complexities of this, where is the PID controller? And what is the importance of showing this with Machinations? One, being able to have a dice roll in this sense, because this isn't specific. It's very generalized, but it's just to exemplify. We can create a randomness that will be a multiplier in the sense that I don't know who's going to stake and how much they're going to stake or when they're going to stake, but we know they're going to stake, okay? And then again, having that go on to a 48, I don't again know how much they're going to stake, but I know that it's going to be a higher number more often. Right now, we can go into this with a Monte Carlo system of our own and see over time, like, oh, say after 100 rolls, how many sevens did we get? Right? We can model out our own bell curve and then just see, and then put it to a 10 by 10 grid or something and look at what exactly it was and model that out ourselves. But another application of long tail financial that we use for this is the steps in between. And again, like Machinations uses Math.js. So there's a lot more that we can do here that's really exciting. We can get really intricate in with these individual steps on what goes through. But we're applying some of our own modeling here to manage the inflation levels that actually go on by simulating a multi-sigmoid bonding curve. And now, unfortunately, I have to share screen again. Okay, I think that worked better. Good, all right. So this is a very basic model, just for really the demonstration purposes of this. But what you see here is an augmented multi-sigmoid bonding curve. But what you can think about this is the fact that, one, when you bring dollars into the system and you're going to mint the native asset, this reserve ratio is your actual liquidity collateral actually in the system in dollars. This top part of the line is actually the AAA token price with the inflated value based off of that minting. As this continues, of course, being a sigmoid curve, it will continue over. As we make in that next step into staking the AAA token and minting staked AAA, this returns again as a second sigmoid bonding curve with a compounded inflation, because now the bottom line is actually the native asset, and this is actually the top. This is the value now of the staked AAA. This continues again when you make the next step, and again, you have new compounded inflation. What's exciting for us is working with Machinations. We can design these systems better in a visual manner for everyone to understand. We can get more in depth with, a dice roll and showing the various opportunities on what that actually looks like, collect all of that data, actually build out an algorithm that actually represents that step or what they want to use or what we could use, even set variables for that once we do it, and then apply it to this. We can actually then build out our own actual curves and have inflation rates to be able to be adjusted. We can then put all of that together and then come back to the Machinations and apply what we found and actually show the rates up and down. And in turn, now we know how to actually code a PID controller into the contracts. Is there any questions?
I think we have some. Let me check the chat.
I can go back to the diagram if I need to, but.
Right, so there was, there's one question on the PID controller. You touched on that. Yeah, but so the general, this core element that you are exploring here.
Just one small thing. I was looking a bit up the PID controller. This is is a proportional integral derivative controller. This is
Correct.
what it is about. Yeah. So it's the application of this relatively older engineering concept from the 20s, but applying it to to economy flows, right?
Yeah, absolutely. Yeah, it's very old. PID controllers are not new, but as far as an engineering standard, We still use them every day in our normal life, and they're one of the most proven models there is. And the fact that it is old school, but the fact is we could actually do this, and we could code it, and we could actually implement it to smart contracts. You know, we can't predict price, we can't predict markets, but we can control the way we react to it. And we can do much better than what we're doing. And so applying a PID controller in this fashion will allow people to really actually model their protocols in a way that doesn't make them bulletproof, but does give them a serious advantage over anyone and everyone else. More importantly, again, the security. The fact that they'll actually, if something does go wrong, we can immediately go back and find out where it was. And if it was a part of the controller, we know how to fix it. Just like when if you need a furnace guy to come over and check what's wrong with your electric board because that's a PID controller, we know which, where, and how to decipher it and quickly fix it and get you back up into heating your house or your protocol up and running. But yeah. I do want to just say too, guys, this has made some rounds in the space, and it's very exciting because people see this, we go through it, we explain it, and they understand it far quicker than anything we had to try to do in the past. And explaining how these things go, it's always been a lot. This really has helped greatly, so it's exciting.
I just wanted to add, there's one interesting application case for another PID controller in crypto, which is RAI, the stable token. And this also is built on a PID controller concept. And you can find sessions explaining the concept of RAI and how this controller works on our YouTube.
Yeah, can I say one thing about that? Hello, I'm Andrew Penland. I also work in TD Academy and am a consultant with Longtail Financial. I think one of the main things that this Machinations PID model really points out is how easy, I think the Machinations opens the opportunity for communities to understand these mechanisms better. Because even though the RAI PID controller has been really well engineered, it actually hasn't been implemented because the community is still debating whether or not to change to that design. So they're able to understand the model better. It can help non-technical.
Sorry, we have a problem here. We have two sounds in parallel. Oops.
Just to continue where I think you left off, it's we felt that very often that because of engaging the community with Machinations, actually you discover that in the community there are people who can contribute awesome ideas to your design, and then you can kind of community hack it, crowdsource economic design in a way that was not possible before, right? Because you can do it on a diagram.
And now, sorry, Andrew, can you unmute again? This was my mistake. Sorry, I didn't want to interrupt you.
No worries. I don't know what you heard, but I was just saying, you know, the people who need to vote to implement a protocol may not have a strong understanding of some of these technical aspects. So being able to express it in a diagram language that they can interact with is just really helpful for education and getting them on board with making the final decisions.
Absolutely. Thanks for this comment, Andrew.
Yeah, we certainly see a lot of the advantage of Machinations is it can be really complicated to explain some of these models to somebody. You know, if you were just to try and or a telephone call explain this PID controller to somebody, it would be very, very hard to kind of explain how these different mechanics come together and how they operate. But actually, especially when you have a model like this and you hit play on it and you start watching the tokens moving around and watching the resources moving around, really makes a massive difference in helping people understand how these mechanics come together and how they operate. It really has a huge impact. And we see this kind of across the board with students that are just starting to learn kind of game mechanics and learn how these systems come together, but also just within teams communicating on how different mechanics operate and how systems like this come together.
Cool. And maybe this is a good moment now to maybe take a step back and compare Machinations with other frameworks. We have CAD/CAD or Token Spice. I know, Jake, Andrew, that you are using CAD/CAD as well. I don't know if you've used Token Spice yet. Maybe you can give us your perspective on when to use CAD/CAD, when to use Machinations, benefits, strength of both of them.
Well, she is right. We haven't used Token Spice too much, but we have actually started an R&D project for agent-based modeling. We're using Token Spice for Olympus itself because it does help validate contracts. And it is very much R&D still, but there is going to be huge implication because, you know, utilizing the nodes and the gates and everything else correlates. They're all little agents. Everything on this board are a bunch of little agents. So it is much easier to communicate in that sense. As far as CAD/CAD simulations, I actually haven't. It probably would. We haven't used it. Like I said, we've run the various different kinds of our own Monte Carlo simulations, and then again, we have our own agent-based simulation that isn't Token Spice that has to do with like the sigmoid curve application on how we gather that data and put it together. But there's definitely a venue for it.
Shake, I think that from my experience, I think the advantage CAD/CAD over Machinations would be if you have something where the like hard math is a part of it, and you might need to call like a hard math function that's native in Python rather than trying to build it up from a lot of the primitives in Machinations. Machinations has the nice advantage in CAD/CAD, you know, they have this diagramming step, but then you still have to translate the diagram to code. And in Machinations, the diagram essentially becomes the code automatically. So I think that's the big distinction I would draw. But
and then,
yeah,
sorry.
We write a lot of our own. LTF writes a lot of its own stuff also. So CAD/CAD is a great tool, and Machinations is a great tool. But
any other comments here from other users? Rodolfo, yeah.
Yeah, I had a question, and this probably will lead into the next kind of like comparison between tools. But one thing that I noticed, I've used Machinations for on and off, I would say, just trying to learn it for a bit. And one of the things, and actually, Matthew, you and I spoke, I think, a few months ago. One of the questions that I had was around how, like, when we look at this system, right, this is a macro view of the system, and it already embeds a lot of assumptions about, you know, the flow of money, so on and so forth. In watching the videos around Machinations, it sounds like for game design, the main kind of like unit of analysis is the player, and then and you're tracking what the player does, and you kind of like tweak what they can or can't do. So it seems like one starts at a macro level, right, the system level, the other one at a micro level, at the agent level. And I'm just curious about how have you guys been able to first of all, is that a fair assessment? Number two, how have you guys been able to combine both, or is that still a work in progress?
Yeah, that's really
Does the question make sense? Sorry. Okay.
Yeah, no, absolutely makes sense. So one of the kind of the founding principles of certainly of our kind of verification program when we're working with Web3 game developers to test and verify their game economy is that we start with what's the player journey first. So our process starts with, right, a player lands on your game, what are they going to do first? What's their interactions going to be? And once we've been through and we've kind of mapped out and built out the logic around the player activity, we then use the output of that model into understanding the macro economy. So really, we kind of start with the granular detail, the ways that the players can interact with the economy. Then we use that as an output to look at, okay, based on different numbers of each of those personas that are interacting with the economy, what impact will they have on the overall game economy? We can start with looking at the macro economy first, but really there's going to be so many unknown variables that are impacting that based on different player behaviors, or the ways that players can interact with the economy. So we always start with the player first and then end up with the macro economy. Does that make sense?
Yeah, yeah. And then how do you clearly, I mean, I don't know, but I'm assuming that you can't model when you're trying to abstract to the, you know, full economy, you can't model each individual player, right, to see what happens. So do you have like middle step aggregations of like, oh, this is type of player A, B, C, and then roll that up, or?
Exactly, yeah. So we'll look at,
Okay.
we'll take the data from our kind of individual players. We'll create different types of personas. So we might look at anywhere between 5 to 10 different types of player personas that we're expecting to get into the game. And then in the macro economy, we're looking at, okay, we're going to multiply that persona data by the number of those players we're expecting. And then we go through and we test it to look at, okay, what happens if we get a huge number of one persona, but a very low number of another persona? And we do with all those kind of what if scenario testing to understand at what point does your worker personas overwhelm your crypto well personas and everywhere in between, those sorts of models.
Got it. Cool. Thank you. I think this is awesome, by the way. I've been a big fan of it.
Yeah.
All right, and that said, we have 3 minutes left. Let me wrap up this session. Thanks, Machinations, for being part of the sessions for this presentation, and I'm sure it won't be the last time we meet in the token engineering community. We meet Machinations. Thanks, LTF, for this awesome presentation. It was just, I guess, an appetizer to your work, and hopefully we'll see more of that. I just want to make you aware of the token engineering fundamentals. Machinations is excellent if you know what you'd like to build. T-Fundamentals is the program to teach you how you do your requirements engineering, how to design your ecosystem, the ecosystem value flows, and then based on that, come up with your components, with your mechanisms, with your flows. And based on that, you can model in Machinations, and you can sign up for this course now. It will be available in Q3 22, and hope to see you there or in one of our upcoming TE hard skills sessions. Thanks again, everyone.
Thank you, everybody. Thank you, Angela. Thank you, Matthew. Thank you, everybody.
The recording will be available
Thank you.
soon. You can find it on our Discord. Don't know if we've had the link here. And then talk soon, everyone. Thanks for joining.
Thank you very much.
Thank you.
Thank you.
Bye-bye.
Can you put the Discord? You think you could put the
Thank you.
Discord link in the chat, kindly?
Which one?
I was going to ask the same thing. You can't click it when it's in the presenter mode.
Oh,
Thank
Yeah,
you,
maybe Paddy
Machinations
can
team.
drop it.
Great presentation. Thank you, Jake. Thank you, Angela.
Got it.
Thank you, LTF, Mike,
Thank you for the link.
Jake.
And thank
Thanks,
you so much,
Matthew,
Jake and
Mihai.
Angela.
likewise. Bye, everyone.
Talk soon.